Let's start with a seemingly straightforward question. How exactly does your brain store a memory of your past experiences? The philosopher John Searle championed what he called the principle of neurobiological sufficiency. It is the idea that the physical tissue of the brain, the neurons, the synapses, the chemical flows, is entirely adequate to explain consciousness and memory on its own. Accepting this premise creates a specific logical requirement. Every dream you have, every mental image you conjure, and every perception you experience must be physically generated from elements stored exclusively within that internal biological structure. Modern neuroscience generally treats this as a settled fact. The consensus assumes that everything from processing a brief flash of light to holding on to decades-old childhood memories happens entirely within the confines of a neural matrix. But this structural assumption rests on fragile ground. To claim that a brain stores conscious experience implies that we already have a working theory of what conscious experience actually is, and exactly how the brain constructs it in the present moment. We do not. Consider this standard biological schematic of perception. Light rays reflect off a distal object in the environment, say a geometric square. Those rays travel through the eye, transduce into photic energy, and the signal terminates inside the visual cortex. That is where processing stops dead. There is no physical mechanism projecting a return signal back onto the square. This creates a spatial paradox known as the coding problem. Your internal world consists of electrical firing patterns, yet you experience a 3D object outside your skull. We have this chaotic storm next to a perfectly stable square. How the brain unfolds its internal code to project this external geometry remains entirely unexplained. Cognitive scientists frequently debate the hard problem of qualia, trying to explain the subjective feeling of redness or the pitch of a sound. In doing so, they routinely bypass this deeper mechanical mystery of how the external image itself is constructed in space. If we cannot explain how a string of neural code unfolds into the perceptual image of the world around us, we have no basis to claim that a memory of that world is simply a modified neural recording. To understand memory, we have to reevaluate what an experience actually is. We do not perceive a universe of static, isolated objects. We experience time-extended events, like the continuous motion of a spoon stirring coffee. Look at this grid representing a tiled surface. In the mid-20th century, ecological psychologist James Gibson provided a mathematical framework for perceiving space. He showed that we gauge depth across the ground through texture density gradients. The horizontal separation between tiles mathematically decreases as a function of distance. When an object moves continuously across that surface toward you, it creates an optical flow field. A gradient of velocity vectors expands proportionally as distance decreases. Even as the visual data rapidly changes, the underlying mathematical relationships remain constant. This is an object's invariant structure, the symmetry laws dictating its rigid physical form regardless of how it rotates, moves, or transforms. These spatial invariants cannot be computed in an instant. Recognizing form requires time. The brain cannot extract the stable geometry of a moving object without simultaneously perceiving the continuous, flowing extent of time in which it moves. The standard cognitive model attempts to explain the perception of time by slicing it into pieces. It proposes that the brain captures a series of frozen, static snapshots and holds them in an iconic short-term memory store. But a sequence of perfectly static states contains zero actual motion. To perceive movement, the brain needs a secondary internal scanner to observe the snapshots, which then requires another mechanism to perceive the scanner's time, creating an infinite regress. The physicist Robert Shaw and his colleague Michael McIntyre demonstrated why the snapshot model fails using a continuously rotating wireframe cube. When observed smoothly, the structural edges clearly define a stable, rigid form. But if you introduce a strobe light to sample the visual input out of phase with the cube's natural symmetry period, the rigid form instantly collapses into a wobbly, distorted, plastic-like blob. The illusion breaks down because forcing discrete, isolated samples disrupts the continuous temporal flow. The brain requires that unbroken flow to compute rigid geometric constraints. The brain does not deduce reality by stitching together a flipbook of static frames. Any theory of memory relying on the brain recording independent instants of time is strictly incompatible with the physics of how perception works. The snapshot fallacy is a byproduct of classical physics, which treats time as an abstract, infinitely divisible line of distinct instants. The French philosopher Henri Bergson recognized the trap in this logic. If you define matter as something that only exists in the absolute present instant, then the past is continually being annihilated. Under that model, the brain is forced to store every fleeting moment of experience, just to prevent it from vanishing into non-existence. But consider the biological reality of an instant. If an instant is an infinitely small mathematical point, it possesses no actual time extent. It has no duration. Modern physics confirms this through the principle of non-differentiable motion. There is no precise, static instant underlying any dynamical physical process. To pause a system to determine its exact static state is to completely destroy its momentum and energy. If motion is continuous and non-differentiable, the brain cannot compute reality or archive memory using static moments. Those static moments do not physically exist to be recorded. If the brain isn't sampling reality in static frames or operating as a biological hard drive, how exactly does it unfold an internal code into a continuous perceptual image? Holography provides a concrete physical method for solving the coding problem. It translates a two-dimensional encoded pattern directly into a three-dimensional spatial field. A holographic interference plate looks completely unintelligible to the naked eye. It appears as chaotic static. Yet the geometric information for the entire recorded object is spread across every point on that surface. Look at the right diagram. In wavefront reconstruction, a specific frequency laser passes through a static interference pattern, unfolding the code into a 3D image. On the left, altering the frequency pulls distinct events from that exact same plate. Holography proves that a localized, static encoded pattern can directly externalize into a continuous three-dimensional reality, as long as it interacts with a passing wave. This brings us to the direct memory model. It proposes a departure from mainstream neuroscience. Your brain does not act as a recording device, and it is not the ultimate storehouse of your past. Instead of a storage hard drive, consider the brain's global, synchronous neural oscillations as a highly complex, modulated, reconstructive wave. Physics suggests that the action of all matter passes through every point in space without loss. If every point in space reflects the influence of the whole material world, then the universe itself acts as a dynamic, scaleless, holographic matter field. When you perceive the world, the brain's neural wave passes through this holographic matter field. It acts as the reconstructive laser, modulated specifically by the mathematical invariance laws of the events you are observing. Because the continuous motion of the universe is non-differentiable, the past is never actually completely destroyed. The physical states of the matter field are never weakly boxed up and relegated to non-existence. Conscious memory, then, is not the retrieval of a decaying biological file hidden in your synapses. The brain is a highly evolved resonant instrument, specifically tuned to directly interact with the persistent, unbroken past of the universe itself.